Dr. Matt. Okay, now we have all the tools we need in order to explain the twin paradox, or so-called paradox, because it's not really a paradox, as you know, well, or as you will know after I explain this to you. This is actually the main reason why I made this series of videos, because I've seen on the web some explanation in forums, in comments, even in videos, trying to explain why we had this and that and blah 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 and blah blah blah, and it was not always that convincing. So I said, hey, I'll give it a shot, and maybe it won't convince you, maybe you won't understand, or maybe I'm wrong. Well, you decide. Okay, so now let's see what the original story was. Here you have two twins, same age. They were born the same day, almost the same time, on the same place, blah, blah, blah. Okay, I take a blue and a pink one, because it's a man, a woman, and I don't want you to say, oh, hey, why is it a man, blah, 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 blah. Okay, I don't care. I have a lot of respect for women as well as for men. Okay? Okay. Now, the woman, in pink here, decides to take a rocket here and go to this star here, very, very far away. So it takes quite a while. And meanwhile, the blue guy here is waiting, okay, and doesn't move from Earth. Now, we assume here, of course, it's a thought experiment. So we assume the distance, doesn't change between the star and the Earth, okay? And after a while, the pink twin comes back. Zzz. Oh, nice. And the thing is, and that's the first paradox, the pink traveler is younger, a lot younger, than the blue twin who stayed on Earth. And that's the so-called, twins paradox. But actually, there is another paradox. If you followed, the previous videos in this series of videos, you know that the relativity says that there's no privileged frame of reference. Therefore, the pink twin here could consider that it's not her who moved away from Earth, but it was the blue guy with the Earth, which was moving away from her and then come back. And if you take that perspective, then if you apply the rules of relativity, well, it should be the blue guy who is younger than she is when they get back together again. Now, what do you say about that, huh? Yeah, I know. So let's take it one step at a time, okay? First of all, we're going to see how we can actually find that one of the twins is younger when they get back together. And that's paradox one, okay? All right. So let's assume there is a distance d between the Earth and the star where, the pink one was traveling. Now, based on what we've seen, let's take some assumptions, First of all, viewed from the Earth twin, the distance, let's say, will be 6 light years, okay? So that means it's a distance such that the light would take 6 years to get there. And then let's assume the rocket, is flying at 0.6 times the speed of light, which is pretty fast, okay? We can't do that right now, but some particles can do that, and so, well, let's assume, it's a thought experiment again, okay? So give me a break, right? Okay, so it's 0.6, that means 60% of the speed of light, okay? So that means that, viewed from Earth, the time to travel from Earth to the star will be 10 years, It's not too difficult, right? Therefore, the round trip will be 20 years. It's not difficult either, is it? Right. Now, let's see what happens. And again, you can look at the previous videos, but as we know, the clock don't tick at the same rate, depending if you are traveling or not, relative to each other. And in our case, viewed from Earth, the clock in the rocket would actually tick slower, with longer periods of time. And the factor that you use to calculate, the time spent in the rocket compared to the time spent on Earth will be 1 over gamma. And gamma if you remember, was this number over there. And if you apply the assumptions we took there, in this particular example, gamma will be equal to 1.25. Okay? All right. Now, viewed from Earth, the traveler's time, will be equal again to 1 over gamma times TDE, which means that instead of 10 years, it will take 10 divided by 1.25, which means 8 years, okay? And 8 years multiplied by 2 means the round trip viewed from the travelers will be 16 years, which means when she gets back to Earth and they compare their age, well, the blue guy will be 20 years older and the pink girl will be 16 years older. Yes, it's just in the numbers. You could also consider that the distance will appear shorter, again because of relativity, and again go back and see my previous videos to understand that. And therefore, if you apply those numbers, you will get 4.8 light years, which means, with that speed of light, you get effectively the 16 years thing. Okay, so that, explains the first paradox, So either you believe in special relativity and there's no more paradox, or you don't and you just go to hell. Just kidding. But that's about the only choice you have. Okay, so now let's look at the second paradox, okay? That's a bit more tricky, and that's where, a lot of videos that I've seen on the web really don't explain, at best, it's not very clear, and sometimes it's even wrong, okay? Because what we can say again is because of the relativity principle, the traveler could say, well, it's not me who's traveling, who's moving away. It's actually, I can consider that my frame of reference is fixed, and it's actually the Earth guy frame of reference which is traveling, and therefore he should be younger than me when we get back together. Apparently that's what the special relativity says. And it's not just apparent, it's actually what is special relativity about. So I've seen, as I said before, I've seen different explanations for that. And some of the explanation invoke the acceleration, because when the pink twin moves away from Earth, well, they stay on Earth and then start to move at 0.6 times c, speed, which is pretty fast. But in order to move from 0 to 60% of speed of light, there's some kind of acceleration, And so some people say, well, this is because of this acceleration thing. And then when she comes back, well, there's a deceleration thing. So that's also why, you can explain there's a different frame of reference, blah, 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 blah. And so some invoke as well, the fact that you use different frames of reference, etc., which, is kind of true, but this is not, the clear and clean explanation as we're going to see. Now, you can also say, well, that proves that special relativity generates paradoxes, and therefore it's wrong. Yeah, there's still some people who believe that, but believe me, there are a lot of proofs. For instance, your GPS system, wouldn't work if it was not, if special relativity wasn't true. So, I think it's a good proof, and there are many other proofs as well. So I don't think that's a very good justification. But then what? Then what? Well, then we're going to need another brother or sister or whatever you call it in order to remove the acceleration deceleration phase, so to make sure that it has no influence, and that special relativity really is about using Galilean frames of reference, which means no acceleration and no deceleration. And therefore, we should be able to explain, this twin paradox without using those, phases and of acceleration, deceleration. which have an extra influence too, as we'll see later, but that we don't need to consider for now, because without that we can still explain the age difference of the two twins when they get back together. Now, how? Well, that's what we're going to see in the next video. Suspense. Sherlock Holmes, Agatha Christie. Well, okay, see you in the next video.